Welcome back to Mr. Leek's free science tutorials. In this video, what we're going to be doing is we're going through the question, what is current, potential difference and charge, and what units are they measured in? Now, current and charge are reasonably common things that are then talked about. Often the one that confuses the most is potential difference. And basically what potential difference is voltage. So whenever voltage is mentioned, we're talking about potential difference and vice versa. And then the key is then, what units are they then measured in? So this here goes through the three different things. We've got current, potential difference, voltage, and charge. Now, quite often what I will do is I'll think about almost this as a bit like water, where if you've got a tap, right, and you attach a hose pipe to it, the current is the flow of the electrical charge. It's how much is flowing, right? That is then measured in amperes, usually shortened to capital A. Potential difference is the push, right? So it's how much electrical work is done by the cell. So it's how much is actually getting pushed. So it's a bit like the tap. If you turn the tap more, there's more potential difference, there's more push out of the tap. That is then measured in volts, capital V. Charge is the amount of electricity travelling in a circuit. Okay, and that is then measured in coulombs, strange kind of spelling of it, and a capital C for then the answer. Right, so to answer the question itself, what we've got is what is current, potential difference and charge, and what are the units they are measured in. Current is the flow of electrical charge, and it is measured in amperes, or capital A, amps. Potential difference is how much electrical work is done by a cell, measured in volts, or V. Charge is the amount of electricity travelling in a circuit, and that is coulombs, capital C. Right? That's the way that you actually answer the question. What is current, potential difference and charge, and what units are they measured in? But I always like to remember it. Current is the flow, potential difference is the push. Thank you for listening. Welcome to Mr. Leek's free science tutorials. What we're going to be looking at in this video is, the question is, draw with a ruler and a pencil a series and parallel circuit, both with one cell and 3 bulbs, and what is the main difference between the two circuits? Right, now just to talk about what each one of the circuits is. You've got a series and you've got a parallel circuit. Series basically means there is one loop. So when you start off with the cell at the top here, there's one route that electricity can go. Okay, so it goes along there, down there, through that bulb, through that bulb, through that bulb, and back round to the start again. There's nowhere else for it to go. A parallel circuit is a circuit with 2 or more loops. So it starts in the cell, it goes through that closed switch there, it goes down to here, electricity can go that way, or that way. So there's basically 3 different routes that the electricity can go. And the good thing about that is if that bulb in a series circuit breaks, the whole circuit goes out. If the bulb in that circuit goes out, electricity can still flow through there, still flow through there, right? So that bulb going out doesn't affect the other 2, whether they're on or off. So back to the question. Draw with a ruler and pencil a series and parallel circuit, both with one cell and 3 bulbs, and what is the main difference? So I've then just drawn a very, very simple circuit, very badly drawn, all right? 1 cell, 3 bulbs, exactly the same as the example before. There is one route for electricity to go. I've then drawn a parallel circuit. This time, 1 cell, 1, 2, 3 bulbs, and electricity can go through there, and through there. All right, so they are then the drawings of a series and parallel circuit, both with 1 cell and 3 bulbs. And what is the main difference between the 2 circuits? The main difference between the 2 circuits is a series circuit is a circuit with one loop. A parallel circuit is a circuit with two or more loops. So, the question, draw with a ruler and a pencil a series and parallel circuit, both with one cell and three bulbs. What is the main difference between the two circuits? Series circuit, one cell, three bulbs, one loop. Parallel circuit, one cell, three bulbs, 1, 2, 3 loops. Electricity can go back. The main difference between the two is a series circuit is a circuit with one loop. A parallel circuit is a circuit with two or more loops. Welcome to Mr. Leek's free science tutorials. This video is going to be answering the question, how is the current, voltage and resistance affected by using a series or parallel circuit? Right, so just as a reminder, what we've got is a series circuit has one route for electricity to go. A parallel circuit has 1, 2, 3 routes for electricity to go. Right, so therefore, if that bulb goes out there, that bulb and that bulb will still light. In a series circuit, if that bulb goes out there, that one and that one go out because the electricity can't get through to them. So, back to the question. How is the current, voltage and resistance affected by using a series or parallel circuit? Right, so, a series circuit. Now, if you think about a series circuit, the current is the flow of electricity. It's a bit like the water flowing through, right? So if this was like a water pipe, the current is a bit like the water that's then flowing through. So if I've got 6 amps, imagine it's water, 6 amps of water, even though that doesn't make any sense. 6 amps of water flowing through there. How much water is going to go through there, there and there? 6 amps, exactly the same. Water goes down the pipe, same with water through there, same through there, same through there, same through there, same through there, exactly the same everywhere. The potential difference is shared. So therefore, if there's 12 volts of potential difference, the push, what happens is the push is shared. 4 volts, 4 volts, 4 volts. So whatever that is then divided up between the different bulbs. The resistance is you add up the components. So whatever the resistance in there is, and there is, what you do is you add them up. So if that's 2 ohms, 2 ohms and 1 ohm, the total resistance will be 2, 4, 5 ohms. In a parallel circuit, it's actually completely and utterly the opposite. In a parallel circuit, what happens is the water comes down here. So you've got 6 amps of water, 6 amps of current, and it's got 3 ways to go. So logically, 2 there, 2 there, 2 there, assuming that all those bulbs are identical. So 6 amps comes down there, 2 amps, 2 amps, 2 amps, and that's the amount of current that then goes through each one of those. The voltage or the potential difference stays the same. So the push from there is 12 volts. So the push there is 12, there is 12, there is 12. The total resistance is less than the resistance value of the smallest individual resistor. So if that is 2, 2, 1, the resistance is less than 1 in a parallel circuit. Now, what I'm just going to do is go back to the question. How is the current, voltage and resistance affected by using a series or parallel circuit? So what you could do to start off with is you could say a series circuit has one route for electricity to go. A parallel circuit has 3 routes for electricity to go if there are 3 bulbs in parallel. How is the current, voltage and resistance affected by the circuit? So a series circuit, the current is the same in all components. The total potential difference for the battery is shared between all the components, and the total resistance is the sum of each of the components' resistance. In a parallel circuit, the total current is the sum of each of the components' currents. So the current there, there and there adds up to make that. Or that gets divided up between those, assuming they're correct, they're exactly the same. The potential difference across all components is the same. So whatever the voltage is there, or the potential difference is there, it's the same as there, there and there. The total resistance is less than the resistance value of the smallest individual resistor. So whatever the resistance is in any of those bulbs there, the total resistance is less than the smallest one. Welcome to Mr. Leek's free science tutorials. In this video, we're going to be answering the question, what are the 4 ways you can increase the strength of a magnetic field in an electromagnet? All right, so keys to this are, there's 4 ways, right? So you need to remember all 4. You can increase the strength of a magnetic field in an electromagnet. Now there's 2 types of magnets. You've got an electromagnet and a permanent magnet. And as the names go, a permanent magnet is a magnet that is always on, a bit like one of those ones that you'll use in your science lab, one of those sort of metal blocks, right? It's always there. And what you have to do is you have to pull off the paper clips or whatever it is. An electromagnet uses electricity to then make the magnet. Now, a good example of one of those is a scrapyard, where what they'll have is they'll have an electromagnet on the end of a crane, and what it'll do, it'll go across, pick up a car and then drop the car. If that electromagnet was a permanent magnet, you would never get the car off again. So the big advantage of an electromagnet is the fact that you can turn them on and off. The 4 ways you can increase the strength of a magnetic field in an electromagnet are these. And in a GCSE exam, what you need to do is you need to be able to write down all of them. So increase the strength of the magnetic field. Firstly, you use a larger current. So more current, the stronger the electromagnetic field. Makes sense. Now, and the way that the best way of actually illustrating this is if you get an iron nail, wrap wires around it, and if you pass current through it, it'll then pick up a certain number of paper clips. If you then have an iron nail and you put more current through it, use larger current, the electromagnet becomes stronger and it can pick up more paper clips. Another way of increasing the strength is to use more turns of wire. So on my finger there, all right, if that was an iron nail and I wrapped 10 coils of wire around it, it would pick up a certain number of paper clips. If I then wrapped 20 coils of wire around it, it would pick up a certain amount more paper clips. More turns. Put the turns of wire closer together. Dead often what I'll see people just wrapping them around all higgledy-piggledy all over the top of each other, and they say, why doesn't it work? All right, what you need to do is you need to have them nicely close together so it concentrates the magnetic field. The last one is use an iron core in the middle. Now I said right from the very start, use an iron nail and wrap coils of wire around it. One of the first things you can do when you're actually doing this experiment is just have a coil of wire, right, with nothing in the middle, and you'll find that the magnetic field strength is incredibly weak. So, the question, what are the 4 ways you can increase the strength of a magnetic field in an electromagnet? Your answer, you can increase the strength of the magnetic field by using larger current, use more turns of wire, put turns of wire closer together, and use an iron core in the middle of the coils.